So last year's talk, just to briefly reprise. How do I get there? There we go. Selecting for, just to very briefly summarize it, selecting for the best individuals can cause cooperative society to collapse. And we also looked at Elinor Ostrom's Nobel Prize-winning work into when you have commons, what are the core design principles that she'd found from research around the world. And these are worth reflecting upon. And of course, in LESS, we've got a variety of commons, common code, common decisions making, and so forth. This year, I'd like to share a few thoughts about learning adaptiveness. And I'd like to start with a section I called Automated Away. Please read this. And I'll fill in some details of what this is about. So, GPT-3 is the world's most advanced learning machine, AI system. It comes out of OpenAI, which is the billion-dollar initiative started by Elon Musk some years ago. And the purpose is to ideally create safe general artificial intelligence. And the context is, if you have a background in AI, you know that one of the big concerns to people in the AI community is what is sometimes called the singularity. If we create a general intelligence AI, then it will be able to create copies of itself, let's say 1 billion, and then cause those to be trained in simulation land, which it itself is setting up in order for those 1 billion children to become more intelligent. All of this is happening in 500 milliseconds. And then pick one of those children and then repeat for 3 minutes and then have a super intelligence beyond anything we can imagine. And this is actually possible. And if this were to happen in secret, who knows? And so as one of several attempts that Elon Musk is doing to try to save the world, going to Mars, moving away from petroleum and so forth, the other is to prevent that. So 5 years ago, he funded OpenAI so that in a transparent, open world, AI researchers would create a general AI that we can all see what's going on, and then perhaps our robot overlords won't kill us all. And GPT-3 is so extraordinary that we're starting to see the beginning of something really powerful. And I'd like to share with you a couple of examples from this.
So last week, GPT-3 was released by OpenAI, and it is nothing short but amazing and groundbreaking. It is the largest leap in artificial intelligence that I've seen, and it is able to produce poetry, text, answer questions, do translation, do design, code. It is a leap in terms of artificial intelligence. In this video, I'm going to give you a demo of some of the technologies and some of the things that GPT-3 is able to do, and some of the demos circulating the internet in just the first few days, and how this technology works and what it means for the future of technology, software, and how we use the internet going forward. So GPT-3 comes from a company called OpenAI. So OpenAI was founded by Elon Musk and Sam Altman. Elon Musk is a prolific entrepreneur. You may be familiar with him from SpaceX and Tesla. And Sam Altman was one of the founders of Y Combinator, a very famous startup accelerator. Combined, they invested over $1 billion in OpenAI to advance the state of the art of artificial intelligence and make sure that artificial intelligence was being used for the betterment of mankind. So let's jump in and take a look at what the tech can do. So the first example is an application called Figma, and the developer has built a plugin to Figma that allows users to enter a description of what they want for an application. So in this example, a user is describing an application with a feed and some icons and a user interface. And when he hits submit, the application actually generates an application that looks very much like Instagram. It has all of the buttons, all of the UI, and a scrolling feed. Just astounding in terms of what it's able to do. The next example is a coding example, and so this is dbuild.co, and they're describing an application that is a basic to-do list application. And so what the software is doing is it's generating a React application, all of the functions and procedures, all of the things that are necessary to create a React component to handle to-do. And you can see it works. You can add items to the to-do list. There's all the events and triggers for handling the interactions of the application, and it's all generated on the fly by artificial intelligence. Just amazing what we're able to do with AI, both the design and development aspects. The next example is in Excel. And so we have a table with headers of company, ticker, and year founded. And we ask OpenAI to complete the table, and it's able to fill in the entire table with the data that it thinks we want. Again, it's pulling this information from its corpus of artificial intelligence, and it's trying to be predictive in terms of what it thinks we want in the table. If we don't agree, or we want to train it a little bit differently, we can queue it with different elements that start in the table. So here I actually want the table to be filled in starting from the newest to the oldest. And so I put Twitter and Facebook and then ask it to predict the table. And it's able to understand what I'm trying to do, and again goes top to bottom all the way in, filling in the year founded information with all the company information. So this example is within Wikipedia. So if you've ever seen a long article, you can't really understand or find the information that you need, you can simply have a plugin where you ask the exact question that you want. So in this example, I'm asking, why is bread fluffy? And it's searching the data and information in that article and generating an answer to my question and giving me a citation and location that I can jump to. So really summarizing the data, making it really easy for me to find exactly what I want from large volumes of text and information that are presented. Because of the vast amounts of information within GPT-3, you can really ask it anything. In fact, you can almost use it like a search engine where you ask it a question, it can give you one result, giving you the citation of exactly where to find that answer. So Google and Apple and Amazon have thousands of engineers working on this problem, and we're able to use this artificial intelligence to solve a very similar problem almost instantly. Just amazing what you can do with the tech. One of the common applications of GPT-3 is translation. So here we can give it an example of an English sentence that we want translated. Your order will arrive in 7 to 10 business days, and ask it to translate into French. We can also use translation to translate things that are written in legalese, this is an NDA, non-disclosure agreement, and translate that into something that a second grader would understand. Really useful. So this is the paper from Open.
That's just the beginning. Just the beginning. We're in early days, and every year they come out with a new release. GPT-3 has 175 billion parameters. 175 billion. GPT-4 will be in the trillions. GPT-5. So you can start to see where this is going to go. And also, GPT-3 is being used to generate future AIs. So you might be familiar with TensorFlow, and on top of that is Keras, which makes it easy. And now GPT-3 is on top of Keras, and you just asked GPT-3 to create an entire deep neural network architecture and train itself. And with a simple command, build a model to classify blah, 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 it will do all of that. And these are early days. And every year it gets kind of 10x more powerful. Moving on in the automation of design, this is applicable to hardware design as well. There's something called generative design, which is starting to evolve with the use of machine learning.
Generative design technology in Fusion 360 enables rapid design exploration by simultaneously generating multiple CAD-ready solutions based on manufacturing constraints, cost, and product performance requirements. This design method starts by framing the most essential geometrical aspects of the problem. Add, remove, or modify to create preserve regions, where geometry must remain, or obstacles, areas to be avoided. Loads are applied to represent the rigors the part must withstand, and from there multiple material options can be designated. Set the objective, whether that be to maximize stiffness or achieve a certain factor of safety. And at that point you're just about ready to start generating results. But before you do that, we'll deviate from traditional design scope to also include manufacturing constraints. Will the part be milled? Do you have access to a 5-axis machine, 3, or 2.5? Could the part be produced on a water jet or plasma cutter? What about die casting? Or do additive techniques provide the best value and performance? All of these options come with unique benefits, challenges, and costs associated with them. After generating, explore the results with different tools and plots to compare each outcome based on the properties that are most important to you, whether that be mass, performance, displacement, or cost. While mass, performance, and displacement are pulled directly from the details calculated during the study, to gauge the cost, Autodesk teamed with A Priori, an industry leader in manufacturing simulation and cost insights. Their costing model interrogates the geometry for features or tolerances that would be complex or costly depending on the manufacturing processes. This allows engineers to strike that right balance between performance and cost. The exported result is a watertight solid body that Fusion 360 users can edit using T-splines technology, or sketches in the case of 2D manufacturing processes, to make any necessary adjustments. Fusion 360 connects generative design and engineering with a fully integrated manufacturing workspace. For those generating machine code and producing parts, this means you can start programming in the same environment and even get a head start while the design is finalized, because the process to update the toolpaths is as simple as regenerating them. Fusion 360 integrates generative design technology and accessible manufacturing options so you can bring optimized solutions into your business today.
So perhaps we're within something like 10 years where 3 engineers in a garage from the ground up could design, build, manufacture an entire car, hardware and software. You know, this is going to be a step change in design and manufacturing and development. And all of this is essentially based upon learning machines, deep neural networks, and so forth. And learning machines are finally starting to get good, as these examples show, at knowledge worker routine expertise. If I think of the path that I've been involved in for the last 45 years as a software developer, essentially automation in various ways, kind of started with routine math onto routine movement, routine information flows, and now we're moving into the automation of routine expertise with powerful task-specific learning machines. So this is going to happen. We're going to get automated. It's just a matter of time. And in the context of hardware-software development, those tasks which are relatively routine, graphics design, that kind of stuff, are increasingly going to be, humans are going to be supplanted, and these will be done by learning machines. Now, if we think of the novelty of knowledge work, so at one end we've got routine expertise, and that will be automated by learning machines. What's at the other end? Well, we might call that adaptive expertise, this framing of routine versus adaptive expertise. Victor pointed out last week to us, and this comes from some work from child psychologists in Japan. And this is still where the human value add is going to be for now. So in short, this kind of stuff, routine expertise, increasingly will be taken over by machines. And when I said human value add for now, my background's in AI, and I would suggest that this paper published by François Chalot last year is going to be in 50 years identified as one of the most important milestone papers in AI, 50 years in the future. Everyone in the community recognizes this is a groundbreaking groundbreaking paper. And it really takes us forward beyond learning machines, which focus on routine task-specific mastery, to the harder problem of adaptive learning machines. A learning machine which isn't good just at graphics design, but a learning machine which is good at learning, adaptive expertise. And in the context of this, Francois had to define how we're going to measure these kinds of learning machines which are good at learning. And so he's coming up with a definition of intelligence which is relevant here. A very important quote: "The intelligence of a system is a measure of its skill acquisition efficiency." This is a way to start to measure what we mean by adaptive intelligence. This is coming. So that kind of leads to the question, what is the relevant measure of human adaptive expertise? Because human routine expertise is not going to be very important in the future. And taking the quote from Francois here, and then updating it, the intelligence or adaptive expertise of human systems is exactly likewise is going to be a measure of its skill acquisition efficiency rather than the efficiency of a particular skill. So to kind of summarize this, because skill and single doing will be supplanted by learning machines. Moving on to adaptive or agile. Back in the day, I think it was in, I can't remember, September of 2000 or something, an old colleague of mine named Bob Martin sent me an email and said, "Hey Craig, I'd like to get together with you and Alistair and Ken and a bunch of other folks in order to discuss the future of XP, Scrum, that kind of stuff." I wasn't able to go at the last minute. The company I was working for asked me to come to France to do some work. But the rest of the folks got together, and while they were there, they created the Agile Manifesto. And here's a quote from Martin that kind of summarized this. The point I want to make from this quote is that the folks that were there were clear what they were trying to suggest with these different approaches. They weren't trying to promote incremental delivery. They weren't trying to promote a series of sprints where you just add more and more. That well-known idea is good, but they were trying to suggest something very different. Not iterative development, but adaptive agile development, where response to change was the important thing. Response to change as opposed to just going through down a product backlog and knocking out more stuff. And picking up Francois Chalot's definition, the one maybe adjective I would add here is a good example of this is, you guys are probably mostly too young to even remember Netscape. And it's not like Netscape didn't know that they needed to adapt. This is picking up on the efficiency part of this. They had created a large product, and because of the competition from Microsoft Explorer with new features, etc., they knew that they needed to adapt. So it wasn't the response to change that was the problem. The problem was the efficient response to change, because they had a mountain of technical debt. So the ability to efficiently, quickly, and gracefully change direction, they couldn't do. In other words, it's not enough to even have the willingness to change. There has to be the effectiveness of change. So when I'm introducing people to the idea of adaptive development, I often break it down into two major areas. One is low transaction costs in your process cycle. the ability to do verification quickly and simply, the ability to deploy, etc. And all of that's wonderful stuff, the ability to deliver in a sprint effectively. But there's more than that to adaptive development. This side here is just good for incremental, iterative and incremental delivery, but it in itself doesn't really fully tick the boxes needed for adaptive development. For that, we also need a low change cost, not only a low transaction cost. And it seems to me that this is where most of the focus of discussion and coaching and most material has been over the last 20 years, is essentially on an efficient sprint with low transaction cost, and that's great. But that was not the vision that was being suggested at the beginning of the adaptive and agile movement. It was about this as well. And I have the impression that this is where the least amount of information and coaching has been focused on, connecting this back to Francois' definition, efficient skill acquisition in new areas. Most so-called agile seems to me to be mostly iterative and incremental, not actually adaptive, changing directions in unanticipated ways that we hadn't before. So what are some of these elements? First of all, I'd like to suggest two relevant domains of adaptiveness. One is for organizational change itself. So imagine an organization adopts something like CMMI, and oh, that didn't work here, so then we're going to adopt Lean Six Sigma, and then that didn't work here, and then we're going to adopt the Agile fad, and on and on. In any event, how easy is it for the organization itself, ignoring the whole product side of the story, but just viewing the organization itself, what is their cost of change to move to new, improved models? That's one area of change and adaptiveness. And then in the world of the product itself, you create something, you get feedback, you need to change direction in unanticipated ways. And so this then begs the question for me, what are some supporting and opposing elements for low cost of change and adaptive expertise in the domain of the organization and the organization itself's ability to change, and then in the product too? Let's take a look at what comes to my mind as some examples. Some opposing examples. Some supporting examples of organizational change. And some opposing examples. Make a few comments about some of these. You've never perhaps thought of that a agile center of excellence was a thing which would prevent an organization from being adaptive, but it is. Because, for example, what if tomorrow people say, well, let's do a different change? Because you've baked in the change X elements then to move away from them becomes more difficult. And another example is change X jargon. This is one of the reasons why I encourage folks to not use jargon, like stories or velocity or most of the Scrum jargon and so on and so forth. Of course, it has its place as an efficient way to communicate ideas, but it locks you into that change fad so that if tomorrow you want to move to a different change fad, you have to undo the jargon and introduce the next jargon. All right. As I often do in these talks, I'd like to do a little exercise. And so our exercise is going to be, because I'm truly interested in getting more ideas in this area, I showed you those lists of opposing elements for organizational design, supporting elements for organizational design, opposing arguments for product adaptiveness, supporting for product adaptiveness. And so what we're going to do is a time box for probably around 10 or 15 minutes where I'd like to invite you to be generating more ideas in these 4 categories, and let's put them up. We can have some more ideas in this space. As a start, though, I'd like to invite whoever would like to photo these 4 slides so that when we start the exercise in a moment, you've got these as input. So you're welcome to just grab your camera and take a photo. Next. And next. And next. So our exercise, and I'll set a timer for 15 minutes, is to generate more of these in these 4 categories. And then when you're finished, please place them up here in these 4 on sticky notes. And then at the end, we'll have more ideas. You're welcome to start.
Thank you.